Okay, we're going to talk about chapter 12 here, analysis of variance. And we're not going to do the whole chapter here either. We're going to do just a couple sections of this chapter. And then we're going to test on it. First of all, there were three things or two things actually we're going to talk about. We're going to talk about the one-way analysis of variance. And we're going to talk about the Sheff test and the 2K test. We are not going to talk about the two-way variance. The use of the one-way analysis, or NOVA, technique to determine if there's a significant difference among three or more means. So we're not looking at comparison to two, three or more. Determine which mean differs using the Sheff or 2K test if the null hypothesis is rejected in the NOVA. And we're probably not going to use the 2K much. I'll talk about it, but we're going to use mostly the Sheff. I'll shrink my line segment down here. Okay. So, introduction. The F test used to compare two variances can be also used to compare three or more means. This technique is called the analysis of variance, or the ANOVA. For three groups, the F test can only show whether or not a difference exists among three means, not where the difference lies. It's important. This tells us, the F test is going to say, is there a difference or isn't there a difference? Now, if there is a difference, we have to do the Sheff test to figure out where the difference is. Now, if there's not a difference, we don't have to do the other tests. One-way analysis of variance. When the F test is used to test a hypothesis concerning the means of three or more populations, the technique is called the analysis of variance, or is commonly abbreviated as the ANOVA test. Although the t-test is commonly used to compare two means, it should not be used to compare three or more. The following assumptions apply when using the F test to compare three or more means. The populations from which the samples were obtained must be normally or approximately normally distributed. The samples must be independent of each other, and the variances of the populations must be equal. So the variances must be equal, the samples must be independent, and the populations must be normally distributed. In the F test, two different estimates of population variances are made. The first estimate is called the group variance, between variance, and it involves finding the variances of the means. The second estimate, the within group variances, is made by computing the variances using all the data and is not affected by the differences in the means. If there is no difference in the means, the between group variances will be approximately equal to the within group variances, and the F test will be close to 1. Do not reject the null hypothesis. However, when the means differ significantly, the between group variances will be much larger than the within group variance, and the F test will be significantly greater than 1. Reject the null hypothesis. So, example. A researcher wishes to try 3 different techniques to lower blood pressure of individuals diagnosed with high blood pressure. The subjects are randomly assigned to 3 groups. The first group takes the medicine, the second group exercises, and the third group follows a special diet. After 4 weeks, the reduction in each person's blood pressure is recorded. At 0.05, test the claim that there's no difference among the means. So we have the information, we have the mean, we have the standard deviations and all that good stuff. So here's it. State the hypothesis. The first step is to state hypothesis, what we have. Pretty easy. Mean 1 is equal to mean 2 equal mean 3, and at least one mean is different from the others. Find the critical value. Now this is a little harder since k is equal to 3, k is the number of groups, n is 15, how many values we have, 15 values, and alpha 0.05, the degrees of freedom numerator is going to be k minus 1. It's important to remember this. Numerator is k minus 1, which is 2. Denominator is 12. So we have to go back in our book again and get our tables. Starts on page 773, and we're doing 0.05. Okay, and this is on page 776. We've got 2 for the numerator, 15 for the denominator, 3 point. Wait a minute now. I say 3.89. Look at here. 2 for the numerator, 15 for the denominator. I got 3.68. Let me look at one thing here. They're very bad at getting their values here. What am I? That's not 15, it's 12. 2 and 12, 3.89. And that's right. So we got our critical value is 3.89. My fault, I looked at the wrong number. Now we're going to compute the test value. And the test value is a little harder to do, so we're going to write down steps. We're going to find the mean and variance of each sample. These were provided in the data, so we already know that. Then we're going to find the grand mean. Now the grand mean is all the values added up divided by the number of values. So we added up all the values here, 116 divided by 15. You got grand mean of 7.73. Now we're going to compute the between group variance. The between group variance is a formula. I'm going to go back here for a second. It says the sum of ni x bar I minus x bar grand mean divided by k minus 1. So on here, we're going to have 5 times 11.8 minus 7.73, our formula, plus this, plus that, divided by k minus 1, which is 2. So our between group variances is 80.07. Now we have to compute our within group variance. Now it's the sum on top of ni minus 1, so it'll be each group minus 1, so 4, 4, and 4. And then our variances of each group, 5.7, 10.2, 10.3, divided by the sum of each group added up. So 104, 8.73. Compute our test value. Our test value is our between variance divided by our within variance, which is going to be 9.17. And then we're going to make our decision. Reject the null hypotheses because 9.17 is a lot greater than 3.89. Summarize, there is enough evidence to reject the claim and conclude that at least one mean is different from the others. So we know there's a mean that is different. The between group variance, there's a couple of things I want to point out. The between group variance is sometimes called the mean squared. The numerator of the formula is to compute mean square variance is called the sum of the square between groups, the SSB. The within group variance is sometimes called the mean square within. And the numerator of the square to compute the mean squared is called the sum of the squares within group. So when we look at a value here, it said between, sum of the squares between divided by the degrees of freedom, we're going to get the mean squared between. Within, sum of the squares within divided by n minus k, number of values minus k. We'll get us mean square within, and if we divide that out, we're going to get our value. So for example, we got sum of our squares. Here's a ANOVA table. Sometimes they'll just print this off. That's it. 160.13 divided by 2 is 80.07. 104.80 divided by 12 is 8.73. We divide those two out, we're going to get 9.17. Our total sum of squares, degrees of freedom, so on down the line. So let's look at another one here. State employees wish to see if there's a significant difference in the number of employees that are interchange of 3 state roles. So we got our values. State the hypotheses, not a hard one to state. Means are the same, at least one mean is different. The claim is always more, at least one mean is different. Find our critical value. K groups, 18 values, 0.05, 2 and 15. The critical value from table should be 3.6. Got my pen working? 3.68. Compute the test value. So we got a little work to do here. Find the mean, these were provided. Find the grand mean. The grand mean is I'll add them all up and divide by how many there is, 8.4. Find the mean between groups. Between groups, 6 times 15.4 minus 8.4, 4 point, and so on down the line. So we get 229.59. Within groups, divide that out and divide, we get 45.5. 4.5 not to go too fast here. So these were our variances for each group. These are the number of values minus 1 from each group, and so on down the line. And I'm wondering if this value is off a little bit here. Because if they say ni minus 1 times this, the bottom should be, the bottom is off. This is written wrong here. This should be 5 plus 5 plus 5. This slide's presentations I've used is a little off on here. I'm going to go back one slide just to look at this formula again. K minus 1 groups minus 1. That's right. Okay, so this should be 15, which they have here, but they divided it out. Compute the test value. So when we compute the test value here, between, we got 5.05. Reject the null hypothesis because 5.05 is greater than 3.68. There is enough evidence to support the claim that there is a difference among the means. Looking at the table, we got 4 divided out, 229, 45, 5.05. We got the values from our table here. That finishes up this part, and then we'll talk about the chef test real quickly.